Yeah, welcome to my YouTube channel once again. So this is a continuation of the first video that I did on differentiation, the introduction. This is going to be a continuation. And in this video and the subsequent ones to come, we're going to look at some of the rules of differentiation. So now we are going to look at the constant function of differentiation. We are going to look at the constant, uh, we are going to look at the constant rule of, constant function rule of differentiation, constant function rule of differentiation. Constant function rule of differentiation. Yeah, so the constant function rule states that given the function fx equal to 1000, if we are to differentiate the function fx equal to 1000, what we are going to get is what? F prime x is equal to 0, like we have seen in one of the example in the introduction. Uh, Note that fx equal to 1000 is the same as fx equal to 1000 x raised to power 0. Yeah. So when you have a constant, it's the same thing as that constant multiplied by x raised to power 0. So if we apply the rule of differentiation, the power rule of differentiation, which is when you are given, a problem in this manner or in this form, if you are to differentiate, the rule states that you multiply the variable by the power. So the power is n, we multiply n by x, and then we subtract 1 from the power, And then if we apply this very rule to this function, what we are going to get is f prime x is equal to what? In this case, we have 0 multiplied by 1000, right? Yeah. And then we have x raised to power 0 minus 1. Yeah. And then with this, we know that when we multiply 0 by 1000, we're going to get 0. Anything multiplied by 0 is 0. And then times, x raised to power minus 1. So, but 0 times x raised to power minus 1 is the same thing as 0. So you understand the constant, function rule, that any constant that is differentiated, will give us, 0 as the answer. So similarly, if we have another function fx equal to, let's say, 47. Yeah, so if we differentiate it, that's by finding the f prime x, what we are going to get is 0. Why? Because our fx equals to 47, is the same thing as what? fx equal to 47 x raised to power 0. So if we're to differentiate this, the f prime will be equal to what? 0 multiplied by 47 and then multiply by x raised to power 0 minus 1. And then we know that this will give us 0. Yeah, so if we have fx equal to 2, our f prime x will be equal to 0. So any constant that is differentiated usually, ends up as 0. 0 is the solution to any constant that is differentiated. So let me just use one more example, like in the form of y equal to 36, So in this case, differentiating will be in the form of dy dx, yeah, assuming that we have an x raised to power 0 here. So in this case, our dy dx will be equal to 0, yeah, because we know that our y equal to 36 is the same thing as y equal to 36 x raised to power 0. So the constant rule is just straightforward and simple. Any constant that is differentiated, ends up as 0. 0 is the solution. So take note of that. Sometimes you may be solving in other, forms, and then you have to differentiate a constant form. Know that when you're differentiating a constant function, the answer will be 0. So thank you very much for watching this. We'll go to the next one, in the next video.